Alright, here is your Algebra 2 first semester final review. It's going to be probably lengthy, so I may have to cut it into two parts. But I'll try and go through them quickly, so that it won't take forever for each problem. Ideally, I'd do a separate video for each problem, but that would take way too long. Alright, so let's kind of analyze each question as we go. The first problem, it's a solve thing, so that means you're trying to figure out what a variable is equal to. Okay, if you look at it, it's got an inequality in it. Okay, now if you recall, inequalities we solve exactly like they're an equation, with one exception, and that is if you ever divide by a negative or multiply by a negative while you are trying to solve it, while you're taking steps to solve it, then you have to flip the inequality sign to keep it true. Okay, some other things you want to notice. The variable we're dealing with is x. This is a linear inequality because these are x's to the first power, and all linear equations or inequalities we solve essentially the same way. Get the x's on the left, get everything else on the right. Eventually you can work it down so x equals or x is greater than or less than something. Okay, everything is outside of parentheses, so we don't have to do any distributing. We just want to take any numbers that are by themselves, like this 4 here, subtract it from both sides. Okay, and I will show each step, and I get negative 5x is greater than 2x minus 21. Next, we'll move the 2x over. It's a single term, so we move it together. It's negative 7x is greater than negative 21. And our last step, to get the x alone, we divide by negative 7. And this is what I was talking about earlier. I am dividing by a negative right here. That's what I've written down, added to the equation to solve it. And so consequently, this inequality has to flip directions to keep it a true statement. So x is less than 3. Okay, and I'll show you a few ways we can represent that. Okay, we'll write it as a solution set, all the x values where x is less than 3. Or we could write show the solution graphically. We're less than 3, so we're going to draw 2 in there, 3 in there, and 4 on our number line. It's an open circle because we just want to be less than the 3 value. And so that is your solution to number 1. Okay, I'll go ahead and put 2 on a separate slide. Hopefully that will give you a better view of it. Alright, so here is problem number 2. Again, it's a solve problem. We're trying to find what x is then. But this time, if you notice, we've got what we call a combined inequality. These are usually combined with an and or an or when it's not written down, but there's two inequalities, and it doesn't say and or. That is an and statement. Okay, so this stuff in the middle, 5 times x minus 3, has to be greater than 7, and it has to be less than 18. And so we write those two equations or inequalities down. We say this has to hold, and this has to hold. So those are the conditions that must be met by the 5 times x minus 3. Now we're kind of back to problem number 1, where we have a single inequality in this statement, and we just got and it's linear, and we're just solving for x. This time we have to distribute the 5, so we get 5x minus 15. Okay. We'll add 15 to both sides. And just this time, I'm not getting x alone on the left. I'm getting x alone on the right, which is fine. Divide by 5. Looks like x is greater than 22 fifths. Okay. So that is 4 and 2 fifths if you like mixed fractions, or 4.4 if you like decimals. Okay, so we know x has to be, if we kind of look at this thing graphically, okay, we'll just draw, because I don't know what the other inequality is going to be. Here is 4.4, and x has to be less than it. Okay, so these are numbers like 3 and 2 and 1, etc. So let's solve the other inequality. We get 5x minus 15 is less than 18. I'll add 15 to both sides. We get 5x is less than 33, so x is less than 33/5. So x has to be less than, and let's write this as a mixed fraction, 6 3/5. Well, 6 3/5 on the number line is up here. And so here's all the values that are less than 6 3/5. Okay. So if we look at this, I quickly realized that I've got some sort of mistake in here, and the mistake is right here in how I interpreted that answer. It says x is greater than 4 2/5, and if you look up in my number line, I've marked numbers like 3 and 2 and things less than it. That red line should be going the other way. And so we want it to actually point this way. It makes a little bit more sense. Now this is an and statement, so where do both the purple and the red conditions get met? They get met in between here. All these numbers in between 4.4 and 6.6 or 6 3/5 satisfy the condition of being greater than 4.4 and at the same time less than 6 3/5. So to write our final solution set, if we want to put it in set notation, it's going to look as follows. It's a set of all x values where x is greater than, and I'm going to use the fractions 22/5 and less than 33/5. Okay. Now graphically, we would go back up here and we'd erase that. We'd erase this, and we would give it the most simplified graph we can give and say it's all of the numbers between there. And ideally, we'd just shade on the number line like this and say it's all of that stuff in there. So that is problem number 2. Onward and upward, we'll go to problem 3. So we can grab it here. There we go. Problem number 3, another combined inequality. This one is an OR statement because it has OR written in it. And we also have 2 inequalities. That's how we know we have to solve 2 of them. Okay. So our first one, let's just solve it right here where it's in the problem. We'll divide by 2. X is greater than 6. The second one, we'll add 6 to both sides. And we'll have negative 3x is less than 21. We're dividing by a negative 3. That's going to flip our inequality. So here comes that flip. It was less than, now it's greater than negative 7. Okay, so let's look at these two on a number line. X is greater than negative 7. That's going to point this way. X is greater than 6. 6 would be up here somewhere. It's going to point this way. Now it's an OR statement. OR statements only have to satisfy one of them or the other one or both. Well, if you look up here, we've got negative 7. Everything to the right of negative 7 satisfies being greater than negative 7. And some of these also satisfy greater than 6. And that's all right. If it's an OR statement, you can satisfy one or both. So our simplest graph for the solution, everything greater than negative 7 satisfies one or both of those. And we'd write our solution set as x is greater than negative 7. Notice open circle. Our open circle indicates greater than, not greater than or equal to. Closed circles, those are the greater than or equal tos. Moving on to problem number 4. Grab the problem from pages. There we go. Here is problem number 4. For an absolute value, again we're solving, we're trying to figure out what x is. Remember in this case, this thing means the distance is more than 12 units. Okay? Distance from 0 is more than 12 units means, this is 0, this is negative 12, and this is 12. It means the stuff in the absolute value has to be more than 12 units or less than negative 12 units. Okay, both of those mean you are more than 12 units away from 0, and that's what this equation is saying. Be more than 12 units away from 0. So, algebraically, we write the quantity, 5x minus 2, has to be greater than or equal to 12. That's this stuff. Or, it's an or statement because notice these point away from each other and they don't overlap. Or, 5x minus 2 must be less than or equal to negative 12. That's for this left half. Okay? And we solve both of those two and figure out what x has to be in order to satisfy these two conditions. So 5x is greater than or equal to 14. Turns out x has to be greater than or equal to 14 fifths, or greater than or equal to 2 and 4 fifths, or 2.8. The other inequality, we add 2 to both sides. 5x is less than or equal to negative 10. Divided by 5, we're divided by a positive, so the inequality stays. So x is greater than 2.8 or less than negative 2. So here's less than negative 2, filled in circle, pointing to the left. Here's greater than, I'm going to write 2.8 there, greater than or equal to 2.8 points that way. To write this as a solution set, we need to write the set x, all the x's where x is less than or equal to negative 2, or x is greater than 2.8. And that would be our solution set, and that would be our graph.